We're into 3.4 and we're talking about non-equilibrium problems for objects on slopes and known directions of acceleration. Well, this one involves a known direction of acceleration. So we're going to talk about this boat, and it's got a mass of 40 kilograms. It has an engine providing a driving force of 80 newtons in an easterly direction. It is also being blown by the wind with a force of T to the north. The boat moves on a bearing of 60 degrees because there are two forces opposing it. It's going on a bearing of 60. I'll draw it in a moment. Find T and the acceleration of the boat. The reason why I'm showing you this is because I'm looking at your book, and it's an example problem, and I just really feel that it overcomplicates this problem. It shouldn't be as complicated as the book makes it seem. So hopefully I can help you out with this. Okay, so I tried to define the variables that were given. I didn't try, I did. And then I drew the diagram. T, the force, it's blowing it to the north at T, 30 newtons this way. Well, that causes it to go 60 on a bearing of 60 degrees that way. So now we are asked, we have to find T and the acceleration of the boat. I recommend you pause it and try to solve it on your own, but if you don't, well, it's your life, it's your decision, but it's just my recommendation. But what we're trying to find, we're going to try to find the hypotenuse here. So I'm going to drop an altitude here. I mean, it's a little bit of trigonometry to get to here. So now we're going to have x cosine, one moment. I wanted to put this here in case you forgot. So this is the cosine of the angle is equal to cos AH, so adjacent over hypotenuse. So I just went ahead and multiplied the x there. So now I'm just going to divide. So I have that there. So I'm just going to divide 30 by the cosine of 30. And I will have the force. I will have this vector force. Okay, and we find out that x is actually 34.64. 34.64 newtons. So that's what this force is. We have to find T. So we have to draw another right triangle. So I'm going to go ahead and draw the right triangle in, so we can determine how hard that wind is blowing to the north. Okay, again, we're going to use the cosine because we have an opposite now. We figured out that x is the hypotenuse, well, the vector that's opposite the right angle is 34.64. So what we're looking for is the cosine of 60 degrees. So we're going to try to find this of 60 degrees is equal to A. So we're going to look for A over H. Well, we have H, so that means that we're trying to find this. So that's adjacent. So let's just call it A over 34.64. Now our next step, well, A is kind of confusing. Can we call it alpha? I'm going to change this to an alpha because we have to find the acceleration also. Okay, so I'm going to say alpha usually is for angles, but we're just going to go with it anyway. So alpha is equal to 34.64 cosine of 60 degrees. And then we're going to find our T. Why am I calling it alpha? Why didn't I just call it T? I'm going back in time. I'm calling it T. What am I doing? Sorry about that. Okay, so I'm going to call it T. I don't want to remake this video, so please forgive my mistake. Okay, so we've got T is 17.3 newtons. So that means that's hard the wind is blowing to the north. And now we have to find the acceleration. So the book does something completely unnecessary, which we don't have to do, which is nice. Now we're at F is equal to MA. F is equal to MA. We already know the boat's going this way, and we already found it. It's 34.64. So 34.64 is equal to the mass times the acceleration. So now A is equal to 34.64 divided by 40. So you get 0.866 meters per second squared. And that's how that one's solved. So hopefully that clarifies what we're doing with part of this unit.